When examining a data distribution of a quantitative variable, whether portrayed by a frequency table or by a graph, such as a histogram, we should look for clear peaks. Does the distribution have a single mound? A distribution of such data is called unimodal. A distribution with two distinct mounds is called bimodal. A bimodal distribution can result, for example, when a population is polarized on a controversial issue. Suppose each subject is presented with 10 scenarios in which a person found guilty of murder may be given the death penalty. If we count the number of those scenarios in which subjects feel the death penalty would be just, many responses would be close to zero. For subjects who oppose the death penalty generally, and many would be close to 10. For subjects who think it's always or usually warranted for murder. A bimodal distribution can also result when the observations come from two different groups. For instance, a histogram of the height of students at a university might show two peaks, one for females and one for males. Consider a data set that contains fuel efficiency in miles per gallon for various automobiles tested in the 1970s. We see here that there are two peaks, thus we call this distribution bimodal. The data in this histogram includes vehicles with 4, 6, and 8 cylinders. Vehicles with larger engines tend to have less highway miles per gallon than those with smaller engines. The distributions of both of these groups, small and large engines, are mixed together in this histogram, giving us the bimodal shape. What is the shape of the distribution? The shape of the distribution is often described as symmetric or skewed. The distribution is symmetric if the side of the distribution below a central value is a mirror image of the side above that central value. The distribution is skewed if one side of the distribution stretches out longer than the other side. To skew means to stretch in one direction. A distribution is skewed to the left if the left tail is longer than the right tail. A distribution is skewed to the right if the right tail is longer than the left tail. How do you decide which summary to use? A few guidelines can help. Use the mean when the distribution is roughly symmetric without outliers. The mean connects nicely to many statistical models and formulas. Use the median when the distribution is skewed or contains outliers. The median provides a better sense of the typical case when extremes are present. Use the mode when describing the most common category or when the data are naturally discrete. For continuous variables, speak of the modal class, the bin with the highest frequency. You can also look at the relationship among mean, median, and mode to diagnose shape. In a symmetric distribution, these summaries coincide. In a right-skewed distribution, the mean typically lies to the right of the median, and the mode is the smallest of the three. In a left-skewed distribution, the order reverses. The following simulates data from a right-skewed distribution and a symmetric distribution and plots them side by side. Notice how the mean and median behave. In the right-skewed distribution, the mean lies to the right of the median, reflecting the pool of larger values. In the nearly symmetric distribution, the mean and median are close together.